In this video, I'm going to go through the solutions for the area and volume test. So in the first question, we're given the area of a triangle, we're given the base, and we have to find the height. So I'm just going to draw a quick sketch. The first thing that I'm going to do is write in the formula to find the area of a triangle. So Achar covering half the base by the height. So now I have my formula. I'm going to fill in the variables that I have. So I know the area is 68 centimeters squared. I know the base is 16, and I want to find the height. So 68 for area, half 16 multiplied by h. So again, I'm going to kind of fill in every single step, but a couple of these could be skipped. So half of 16h. So half multiplied by 16h is going to give me 8h, because 16 divided by 2 gives me 8. So it's going to be 68 divided by 8 is going to give me h. So h is going to be equal to 8.5. So there's always a few things we need to watch out for at the very end. We need to check, do we need to round? So not for this question. And the units. So we need to put in our centimeters for the units for the height. Okay, so to recap, we're asked to find the height, we're given the area and the base, we write down a formula first, we fill in the information that we're given, and then we simplify to find the one missing part. Part 2. We're told that we have a semicircle and a rectangle. This shape represents a window, and we need to find the total area of the window. We're told that the length of one of the sides of the rectangle is 90 centimeters, and the length of one of the other sides is 70 centimeters. So with any of these kinds of irregular shapes, we need to break them down into the shapes that we can find the area of. So first of all, the area of our semicircle. We go to our log tables, we find the formula for the area of a circle, which is pi r squared. And because it's a semicircle, we're going to divide it by 2. So let's do that part first. So if we take our semicircle, we know that the length of one of the sides of the rectangle is 70 centimeters. So that means the radius of the semicircle will be 35 centimeters. So now we know our radius is 35. Once we have the radius, we can find the area of the circle. So we just fill it in. So we have pi multiplied by 35 squared, and that's divided by 2. So using our calculator, this is going to give us 1924.2255. And this is centimeters squared. Now we're going to find the area of the rectangle. So rectangles and squares we're not given any formulas for, we need to know it off by heart, but it's straightforward enough. So we know it's fad fall ahead. So it's going to be 90 multiplied by 70, which is going to give me 6,300 centimeters squared. So the last step then is to just find the total area. So we just find the sum of 1924.2255 plus 6,300. So we get 8224.2255. So again, at the end of the question, we need to go back and check and see if we need to round. So in this question we do. We need to round to the nearest whole centimetre. So that's going to give us 8224. And again, our units were given centimetres, so the area is going to be centimetres squared. In the last part of question 1, we need to find the area of a shaded section of a shape. So we're given a circle, there's a triangle in one of the circle's quarters, and we need to find the area of this shaded part here. So when it comes to shaded areas, again, it's usually breaking the shape down into kind of shapes that we can't find the area of. So if we just highlight first of all this section of the circle. Okay, We know, because the triangle is a right angled triangle, which we're told, that this section that I've highlighted in blue here is a quarter of the circle. So I'm just going to kind of draw it out here. This is a quarter of the circle. Inside that circle we have a triangle. So again, just drawing a smaller sketch here. So we find the area of the full quarter of the circle, and then we subtract the area of the triangle, then we'll find the area of just that shaded part in here. Okay, so the sketch is a little bit rough, but we get the idea. So again, we're using the formulas that were given in our log tables. So if we look and we find the area of the full circle, we have pi r squared again. I'm just looking for the area for the quarter, so I'm dividing it by 4. And in the question we're given the radius, which is 7 centimeters. So the area is going to be pi multiplied by 7 squared divided by 4. And using our calculator, we'll find that this is 38.4845. So again, this is the area of a quarter of the circle. Now what we're going to do is find the area for the triangle. So for a triangle, we have half our base by our height. This is going to be half of 7 by 7. So again, using our calculator, this is going to give us 24.5. So to find the area of the shaded part, it's the quarter of the circle minus the area of the triangle. So it'll be 38.4845 minus 24.5, which is going to give us 13.9845. Again, we're asked to give our answer to the nearest centimetre. So this is 14, and to include our units for area, it's going to be centimetres squared. So in question 2, we're dealing with a cylinder and a cone, so I'm just going to draw a quick sketch of both. So one of the first key pieces of information that we're given is that the volume of both solids is equal. So the volume of the cylinder is equal to the volume of the cone. The first thing we're asked to do was to find the volume of the cylinder in terms of pi. So just to note as well, all the units that we're using in this question are centimetres. Okay, so the first thing that I do, I write out the formula that I need to find the volume of the cylinder. So the volume is equal to pi r squared h. Again, this formula is in the log tables. So we're going to identify what we have for the cylinder. Our radius is 6 and our height is 20. So I'm just filling those values in. So our volume is going to be pi multiplied by 6 squared multiplied by 20. So because it's in terms of pi, I leave pi as it is. 6 squared multiplied by 20 is going to give me 720. So the volume in terms of pi is 720 pi. The next part of the question asks us to find h. So we're using the fact that we know that the volumes are equal. So again, I start off by writing in the formula for the volume of a cone. Again, this is in the log tables. So we have 1 over 3 pi r squared h. For the cone, my radius is 12, and we're looking for the height. We know that the volume is 720 pi because it's equal to that of the cylinder. So for my volume, I fill in 720 pi, and I fill in everything that I have on the right. So 1 over 3 pi 12 squared h. So I have pi on either side, and I'm multiplying all values on either side, so therefore my pi is going to cancel. I can think of it like I'm dividing both sides by pi. So I have 720 is equal to 144 divided by 3 by h. So I've just simplified 12 squared multiplied by a third. So I have 720 is equal to 48 multiplied by h. So 720 divided by 48 is going to give me h. So I get 15. Again, just a very last kind of step, we need to ensure that we include our units. So we're given centimetres at the start, so we have 15 centimetres for the height of the cone. Part 2 of question 2. Given kind of an irregular shape. Again, I'm just going to quickly draw out a sketch. So any 3D shape that has a uniform cross section is a prism. So it means that if we were to slice this shape anywhere, it would be the same, it would have the same face. In order to find the volume of these shapes, again, we're given no formula, like with the square and the rectangle. So what we do is we find the area of the face of the shape, multiply it by how far it goes back, so I want FOD, and that will give us our volume. So the area of the face, multiply by how far it goes back. So I'm going to fill in the dimensions that we're given. We're told 10 is the base, 8 is how far it's going back, we're given 4, 5, and 3. So now all I have to do is find the area of the front face. Again, I'm just drawing a very quick sketch. In order to find the area of this shape, I need to break it down into two smaller shapes. So I find the area of the smaller rectangle and the bigger rectangle. So we have 4 and 5, so the area of the smaller rectangle is going to be 20. And we have 10 and 3, so the area of the bigger rectangle is going to be 30. Now obviously this isn't to scale or anything, it's just a quick kind of sketch. So the total area of the face is going to be equal to 50. So 20 for the smaller one, 30 for the bigger one. So the volume is going to be equal to 50 multiplied by how far it's going back, which is 8. So the volume is going to be equal to 400 centimeters cubed. In the last part of question 2 then, we're using our formula to find the approximate area of an irregular kind of shape. So the formula that we're given is h over 2, y1 plus yn plus 2 by y2 plus y3 plus dot 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 all the way to the second last y, which is yn minus 1. So what we need to identify first in this question, what is h and what are the y's? So the h that we're given is 15 meters. Our first height is 17 meters. Second one is 12. Third one we're not given, it's just labelled as k, which we're obviously going to need to find. Our fourth one is 27 meters. And the last one, because it ends back down kind of on the ground, y5 is equal to 0 meters. So now we just have to fill these values in and we need to find k. The other key piece of information for this question is given at the very start. We're told that the approximate area is equal to 1087.5 meters squared. So if we think of it in terms of an equation again, we have the formula that we need to use. We have all of the variables except for one, which is k. So we need to just fill in and solve for k. So that's what we're going to do first, just fill our values in. So to simplify this formula a little bit, so first of all we have 15 over 2. So the part that includes ends can sometimes be a little confusing. So we remember it's the first height, which is 17, the last height, which is yn, which is 0, and twice the sum of the heights in the middle. So it's our y2, y3, and y4. So we have 12 plus k plus 27. After you've done that, really it's just making sure that you take it step by step so you don't make silly mistakes with brackets and multiplying. It's simple kind of algebra or arithmetic here. Okay, so we have 1087.5 is equal to, so 15 over 2 is going to give me 7.5. 17 plus 0 just gives me 17, plus twice, and I'm going to simplify what I have here in the brackets first. So 12 plus 27 gives me 39 plus k. Okay, now I'm going to take another step to get rid of the brackets. Inside the brackets, so leaving my 7.5, leaving my 17, get rid of the brackets inside. So 2 multiplied by 39 is going to give me 78. 2 multiplied by k gives me 2k. So again, sometimes a few of these steps can be skipped, but I'm just doing all of them to make sure that we know exactly what order we're doing things in. So 17 plus 78 gives me 95, and I have my 2k. So the next step, I'm going to multiply in my 7.5. So I get 712.5 plus 15k. Now I move every term without a k onto the left, so I can slowly kind of single out the k. So minus 712.5 equals 15k. 1087.5 minus 712.5 is going to give me 375. And then 375 divided by 15 equals k. So we find that k is equal to 25. Again, these units were given at the start, which is meters. We have 25 meters for k.